Instructors in this video program will demonstrate selected intermediate maintenance procedures for a Solar GS4000 turbine. Intermediate maintenance procedures typically should be performed after every 4,000 hours of engine operation. When completing maintenance work, always check your operation and maintenance manual for specific procedures and safety precautions. Warnings and safety precautions are given throughout the video program. Always follow these precautions when completing maintenance procedures.
Calibration of a gauge can be accomplished using several different methods. In the comparison method, the gauge can remain in the control panel and be calibrated using a master test gauge. Another method is to remove the gauge from the panel and calibrate it using a dead weight tester. In the following procedure, you will calibrate a gauge using the comparison method. To perform the calibration, you will need a master test gauge, several high-pressure flexible lines with the correct AN fittings, proper fittings for master gauge connections, 2 to 4 needle valves rated for the pressure in use, and an acceptable pressure source. Warning: do not use flammable gases as a pressure source. Their unstable characteristics create a safety hazard which could result in damage to the equipment and cause personal injury. In some cases, system pressure can be used as the pressure source. If system pressure cannot be used, an external pressure source must be supplied in order to perform gauge calibration. In this procedure, we will use an external pressure source. First, close the manual shut-off bleed and instrumentation valve, located at the rear of the control console. Note, when using an external pressure source, the valve must be in the closed position. Warning: be careful when removing the test connection cap in the next step. Pressure trapped in the connection can cause personal injury. Slowly remove the test connection cap. Next, connect the hose from the master test gauge to test connection on the manual shut-off bleed and instrumentation valve. Be sure all connections on the master test gauge assembly have been tightened. Then place the assembly on top of the panel so that it can be reached from the front. Now, at the front of the panel, connect the external pressure source to the master test gauge assembly. Caution: in the next step, slow, even pressurization and depressurization is essential for accuracy and long life of the gauges. While holding the master test gauge assembly in position, slowly open the three-way hand valve to allow pressurization of both the master test gauge and the gauge to be calibrated. Increase supply pressure until the master test gauge stabilizes at the normal system operating pressure. Now, compare the pressure indication on the master test gauge to the gauge being calibrated. If the gauge requires adjustment, you would use the calibration screw on the gauge face. Further in the tape, we will go through this procedure in the lab. Once the gauge has been calibrated, slowly decrease, then increase the pressure to check gauge repeatability. When the calibration is complete, bleed the external pressure source to 0 and disconnect it. Next, remove the master test gauge assembly from the manual shut-off bleed and instrumentation valve. Reinstall the protective cap. Then tighten the cap and open the valve. When the calibration of the gauge is complete, document discrepant items, return the unit to service, and perform a leak check of connections used during gauge calibration. We will now go to the lab and demonstrate gauge adjustment. Using the pump from the dead weight tester, pressurize both the master test gauge and the gauge to be calibrated. Once the master gauge indicates operating system pressure, check the indication on the panel gauge. As you can see, the panel gauge is out of calibration and must be adjusted. To do this, we must first remove the retainer, being very careful not to damage the gauge glass. Next, apply tape to the glass and carefully remove it from the gauge. Now use the calibration screw to correctly set the gauge. Once this has been done, recheck the calibration by decreasing, then increasing the pressure. This is done to check gauge repeatability. When calibration is complete, decrease the pressure. Remove tape from the gauge glass. Next, clean the glass and install it in the gauge. Then carefully install the gauge glass retainer, making sure it is seated. Once this has been done, remove the gauge and reinstall it in the panel. Using the same test equipment, you will be able to calibrate a differential pressure gauge, sometimes referred to as a delta P gauge. Note, there are two test connections on the back of the delta P gauge. These connections are labeled high and low. First, connect a line from the pressure source to the connection marked high on the delta P gauge. Be sure to tighten all fittings prior to applying pressure. Once the fittings have been tightened, check to be sure the low side of the gauge is vented to atmosphere. Next, position the gauge so that it can be easily read when applying pressure. Then increase pressure to both gauges. In this example, we will use 25 pounds as our calibration point. Once you have reached the correct pressure on the master test gauge, compare the reading to the delta P gauge reading. Any difference in readings indicates an adjustment is required. Use the adjusting screw on the face of the gauge to rotate the face to the correct setting. Now decrease, then increase the pressure to check gauge repeatability. Both indicators should indicate the same. If an adjustment is made, recheck the gauge repeatability. Next, decrease test pressure. Then remove the delta P gauge from the test equipment. Reinstall the gauge in the control panel. Perform a leak check on connections when the unit is returned to service. Note, liquid-filled gauges should not be disassembled for field calibration. These gauges should be calibrated in an instrument shop capable of replacing the O-rings and gauge fluid. If the gauge is field disassembled and the cover O-ring seal damaged, oil leakage will occur, and the life expectancy of the gauge will be seriously shortened.
Calibration of the speed control system is performed as part of the intermediate maintenance inspection to verify the proper operation and set points of the engine speed control unit Z283. Be sure to check your operation and maintenance instructions for warning and safety precautions that pertain to speed system calibration. Prior to calibrating the unit, shut down the unit. Now turn the master switch off. Then tag the switch. Caution: be sure the pulse tube is complete prior to securing the fuel and service gas. Next, secure the gas supply if the package is equipped with a gas fuel or gas start system. Open the door of the control console. With the power off, remove the Cannon plug connector P283 from the control unit Z283. Inspect the engine speed control box for damage and corrosion. Inspect the Cannon plug connections for damaged, broken, or corroded pins and loose or broken wires. Be sure to clean any corrosion if present in the control box or Cannon plug using an electronic parts cleaner if available. Avoid using cleaning agents that leave a residue. Obtain a signal generator, digital counter, and volt-ohm-meter for this procedure. In this demonstration, we'll be using a turbine test set, otherwise known as TTT. Other equivalent equipment may also be used to complete this procedure. The first step in the calibration of the engine speed control is the mechanical zeroing of the engine speed meter M183. This step should be done with the power off. To mechanically zero the meter, use the adjusting screw on the base of the meter. Note, clean the meter face if needed with a dry cloth or eyeglass tissue. Avoid putting your hand on the meter, since static charges in your hand may affect the meter's accuracy. Next, attach the test equipment to the control system connections as follows. With all of the speed control system parts installed and connected, attach the power leads of the TTT to the 28-volt DC supply terminals in the control console. Now, connect the two output leads to the source A signal generator at the output terminals on the TTT. Check the wiring diagram for the proper wire locations. Then disconnect the lead that goes to the magnetic pickup from the terminal strip. Tape the lead to prevent it from contacting the other circuits. Now connect the output leads of the signal generator to the terminal board wire that goes to the electronic speed monitor. Next, attach two additional leads to the source A signal generator. Attach the other ends of the leads to the input jacks of the VOM. Now, verify the part number and the dash number of the speed control unit with applicable schematic drawings or service bulletins. Be sure the control unit is the correct one for the application. Next, carefully remove the speed control box cover. The rubber plugs under the cover may be loose and you don't want to lose them. Now, turn on the control console power. Then place the master switch S01 to local. Now, turn on and adjust the output of the signal generator to between 3 and 20 volts RMS. During our test, we'll set the output at 12 volts RMS. The output can be measured with the voltometer. Note that when we turn on the signal generator, the built-in digital counter illuminates its display of the output frequency. Be sure that the selector switch is on source A. In the following steps, you'll calibrate the engine speed meter at 100% speed. Note the Hertz values given for the set points in this job program are typical values which may not be the same for every package. Always refer to the electrical schematic to verify the set points for the package you're working on. First, adjust the frequency of the signal generator for 100% speed. 8,717 Hertz for 50 cycle generators and 9,967 Hertz for 60 cycle units. Remember, the voltage output should be 12 volts RMS nominal. While approaching 100% speed, notice that both the counter and speed meter represent visual displays of engine speed as simulated by the signal generator frequency. Check the speed meter. It should read 100% speed. If it doesn't, adjust the M, or master adjust, on the speed control unit. Note, avoid parallax when reading the meter during this adjustment. Be sure to look at both the needle surface and the scale surface from a 90-degree plane of vision to obtain a correct meter reading. After you've adjusted the speed control meter, set signal generator for a 0 output. Note that speed meter may not drop all the way to 0 as long as 28-volt DC control power is applied. Do not try to adjust the meter at this point. The meter is calibrated at 100% speed. In the following steps, you'll verify the individual engine speed set points. First, verify set point number 1. Set the VOM to read DC volts on the 60-volt scale. Note the wire number for any set point can be obtained from a schematic and wire diagram. Then connect the test leads of the VOM to the 15% speed contact wire leads at the terminal strip in the control console. Next, adjust the output of the signal generator for the frequency equivalent of 15% speed plus or minus 30 Hertz. This is the transfer point of switch number 1. Be sure to check the electrical schematic to verify the set point frequencies. All sets may not use 15% speed. While slowly approaching the set point, observe the volt-ohm-meter for an indication of switch contact transfer. The needle will change on the scale at switch transfer. Contact transfer should occur at the frequency equivalent to 15% speed plus or minus 30 Hertz. Check the speed meter. It should read 15% speed. However, the meter may not be accurate at the lower end of the scale. Remember, we're calibrating the switch set points and not the meter. If transfer does not occur at the correct frequency, adjust potentiometer number 1 on the control box face. Decrease and slowly increase the signal generator frequency and observe the VOM. Continue this procedure until the set point is correct. Next, verify set point number 2, the same procedures as before. Refer to the schematic and wire diagram for the proper terminal points in the console. Move the VOM test leads to the wires attached to the contacts for 66% speed. Slowly increase the signal generator frequency to the set point value. Observe the switch contacts transfer as indicated on the VOM. Check the speed meter. It should read 66% speed. If the switch does not transfer at the correct frequency, adjust pot number 2. Decrease and slowly increase the signal generator frequency until the correct set point is reached. Again, the tolerance is plus or minus 30 hertz. Next, verify set point number 3 using the same procedures as before. Move VOM test leads to the wires attached to the switch contacts for 90% speed. Adjust the frequency output of the signal generator to transfer the contacts at 90% speed. Approach the set point slowly and observe the voltmeter for the switch transfer. Check the speed meter. It should read 90% speed. If the switch does not transfer at the 90% speed, plus or minus 30 hertz, adjust pot number 3. Decrease and slowly increase the signal generator frequency until the correct set point is reached. Observe the voltmeter for the switch transfer indication. Next, verify set point 4, which is the overspeed malfunction set point. Move the voltmeter test leads to the contacts for 108% speed. Slowly increase the frequency output until transfer occurs. Observe the voltometer for this indication. Note that the malfunction lamp DS3 illuminates at this time. Check the speed meter. It should read 108% speed. If the switch does not transfer at 108% speed, plus or minus 30 hertz, adjust pot number 4. Recheck set point after each adjustment. Note that 108% speed switch uses both normally open and normally closed contacts. The correct operation of both sides of the contacts should be verified. Move the VOM test leads to check the other set of 108% contacts. Adjust the frequency output until transfer occurs. Observe the VOM for transfer indication. Check the speed meter. It should read 108% speed. If both sides switch do not transfer, control units be replaced. Recheck the set point after each adjustment. Now, while the equipment is still set up, use a schematic and check that you've verified the set points of all the switch contacts in use. Some applications use both normally open and normally closed contacts on switches other than 108% speed. Be sure to verify their set points. Failure of any speed switch contacts in use is cause for replacement of the control box. Now you're ready to recheck the speed control unit set point at 100% speed by approaching the frequency from below 100%. Begin by lowering the signal generator frequency below 100% speed. Observe the digital counter and speed meter for a frequency drop. Check that the speed meter indicates less than 100% speed. Now, slowly increase the signal generator frequency. The speed meter should indicate 100% speed at the correct input frequency. If the speed control meter does not indicate 100% speed, readjust master potentiometer. Then go back and recalibrate all set points. If sim calibration does not repeat after 2 attempts, replace the speed control box. If the meter indication is correct, secure power to the test equipment and to the control console. Then remove the leads from the test equipment. Now reconnect the magnetic pickup output wire to the terminal's contact. When the package is started, verify the voltage output of the magnetic pickup. Procedures for verifying the voltage output are covered in Job Program 4 of this videotape.
Maintenance of the primary fuel shutoff valve may be required at more frequent intervals than 4,000 hours. Maintenance is required when the valve indicates even the slightest inclination to stick, or if the gas fuel valve fail shutdown occurs during startup and as part of the intermediate inspection. The primary fuel shutoff valve, or reversa valve, is also used as the shutoff valve for the gas or air start, auxiliary lube, and auxiliary seal oil systems on Solar equipment. Now, with the exceptions of locations, system pressure source, and removal and replacement considerations, the inspection procedures are the same for the valve in all applications. Shut the unit down. Turn the master switch off and tag it. Caution. Post-lube of the engine must be complete prior to securing the service gas or the electrical power which drives the post-lube pump. Turn the fuel and service gas off and tag the valves. On some units installed in the field, customer modifications may include a pilot gas shutoff valve. Secure this valve and tag when used. Prior to any disassembly of system components, the pressure must be let down. Gas will be trapped between the manual shutoff and the primary shutoff valves. Pressure will also be trapped in the pilot gas system, which is supplied ahead of the primary fuel shutoff valve. Install a flexible line between the fuel gas strainer and the overboard gas vent system manifold. Pressure from the gas supply line should not be allowed to escape in the area of the package. If no valve exists for the bleeding of this gas to the vent, pressure may have to be allowed to escape from a pressure fitting. Warning: the escape of gas into the atmosphere can be a serious hazard. Use extreme caution to avoid any source of ignition and ensure that the area is well vented. Before the system is pressurized, a quick-acting 1/4 turn valve and plug should be installed in the gas strainer cap. Materials required for this job are one VersaValve overhaul kit for each valve, Dow Corning FS 3451 fluorosilicone lubricant. Remove the 2 bolts from the top with a hex wrench. Remove and discard the 4 O-rings from the bottom plate. Use a 1/4 inch hex wrench to loosen the 8 screws and remove the pilot caps. Remove and discard the O-rings from the pilot caps. Next, remove the spacer. Place the end of the valve with the detent cage inside a small box and remove the cage and plunger from the valve. Be careful not to lose any of the balls and springs as the detent cage is removed from the valve. With your fingers, push the plunger assembly toward the detent cage assembly of the valve. Remember, remove the detent assembly cage and the plunger at the same time. Notice the holes for the springs on the side of the detent cage. Note, there are 2 different types of detent cage assemblies. There is no way to distinguish which is in the valve from the valve's exterior appearance. As you have seen in the disassembly of the valve, one type has no retaining caps to prevent the escape of the springs and balls. The second type, however, has pressed in retaining caps which prevent the springs from flying out during the disassembly of the valve. Always enclose the valve to prevent the loss of the springs during overhaul. The plunger must now be disassembled to replace the O-ring and lock washer. Do not use screwdrivers, pliers, or other metal materials that can scar or burr the machine surface of the valve. Place two 1/8-inch thick pieces of bar stock in the vise to serve as a holding stand. Place the slots of the stub shaft end onto the metal bars. Use another piece of 1/8-inch stock in the upper grooves to loosen the two plunger halves. Now remove and discard the large O-ring and the smaller one from the shaft. Remove the washer from the bottom half of the plunger. Clean the plunger in Stoddard solvent. To reinstall the plunger, seat the washer and replace the two O-rings. Tighten the plunger assembly with your hand. Then torque it down lightly with the metal bar. Clean all of the parts in Stoddard solvent. Clean the O-ring grooves on the sleeve. Inspect the sleeve for burrs and scratches. Use a number 400 sandpaper to smooth the rough spots. Lubricate the parts. Lubricate each of the O-rings and install in the grooves. Use clean, dry air to blow out the gas ports in the valve body. Make sure that each port is open and clean. Install the sleeve assembly. Some pressure may be needed to seat the sleeve. Install the detent cage with the spring in place. Apply pressure to each spring as you seat the detent cage. And last, install the end cap with the lubricated O-rings in place. Install the 4 bolts and torque to 12.2 to 16.3 Newton meters, or 108 to 144 inch-pounds. Invert the valve body to install the plunger. Note that the detent cage is at the bottom of the valve and the index pinhole is at the top. Carefully work the plunger into the assembly. Next, install the spacer. Install the end cap and 4 bolts. On the mounting surface of the valve, install the 4 O-rings. Install the valve on the package by matching the index hole and guide pin on the skid. Tighten the 2 captive screws. Torque the screws to 27 to 34 Newton meters, or 240 to 300 inch-pounds. Reconnect the plumbing used to bleed the system. Tag the valve for the leak test at the end of the fuel system maintenance operations.
Magnetic pickups G383 and G351 are mounted on the right and left-hand side, respectively. respectively, of the reduction gear unit housing. These pickups sense the applicable number of rotating gear teeth at the gear unit countershaft gear assembly and transmit output signals which are sensed by the engine speed control unit Z283 and the electronic load speed sensing control Z251. The maintenance procedure for these two pickups is the same except for connections. They should be inspected after each 4,000 hours of operation. The following procedure will be demonstrated on G383 only. However, the same procedures will also apply to G351. Check your operation and maintenance instructions for warnings and safety precautions prior to performing maintenance. The voltage output of the magnetic pickup should be checked as part of the intermediate inspection. Voltage output must be checked when the engine is operating at 100% speed. Determine the wire numbers and terminal connections in the control panel, the pickup, by checking the schematic. For G383, find the leads going to engine speed monitor Z183 and tag them. Next, set the multimeter to the 300-volt AC scale. Connect the two leads from the multimeter in parallel to the lead from the magnetic pickup, connecting one lead to each wire. Multimeter should read very low. However, if the reading is high, an adjustment must be made. If the voltage is low, continue to switch the scale down until you're able to read the correct voltage. The multimeter read between 3 to 20 volts, and ideally, the output would be 12-15 volts AC. Record the voltage. If it's below 3 volts or above 20 volts, the magnetic cup needs to be adjusted. Remove the multimeter leads. Warning: the engine must be shut down to adjust the magnetic pickup. Under no circumstances should the engine be rotated while the magnetic pickup is out of the engine gearbox. The next step of the inspection is to check the loop resistance. Shut down the unit. Turn the master switch off. Caution: be sure the post loop is complete prior to securing the fuel and service gas. Turn off fuel and service gas and tag them. Turn off the circuit breakers, tag them. You'll need a VON for this inspection. Begin by zeroing the meter on the R times 10 scale. Next, remove one of the wires at the terminal that leads directly to the magnetic pickup. Connect one of the meter leads to the loose wire and the second lead to the pickup wire at the terminal strip. Be sure that you connected the meter of the wires that lead directly to the magnetic pickup and not through the solid state device. Check the reading on the multimeter. It should be 55 to 95 ohms. If the resistance of the pickup is not between these values, first check the correct connections. If the connections are correct, check the pickup for electrical short. If there is a short, try to repair it and check the resistance again. If the resistance of the pickup is beyond the range, or if there is a short, replace the pickup. During this inspection, you'll check gas producer seal and combustor drains for oil passage while the post-lube pump is operating and the lube oil is hot. Inspection of the gas producer and combustor drain is performed as a part of the intermediate maintenance section. Check your operation and maintenance instructions for warnings and safety precautions prior to performing maintenance. Shut down the units. Turn the master switch off and tag it. Warning, you'll be working on a hot engine during this inspection. Take appropriate steps to prevent burning yourself. First, check the number 2 bearing seal. This can be done by removing the forward combustor drain line connection. It's located at the 6 o'clock position. Once the line has been disconnected, check the combustor drain fitting for oil leakage. Next, you'll check the number 3 bearing seal. This can be done by removing the rear combustor drain line connection located at the 6 o'clock position. Once the line's been disconnected, check combustor drain fitting for oil leakage. When you've completed your check, reinstall the combustor drain lines. The last check you will perform is on the number 4 bearing seal. This can be done by removing the drain line from the exhaust collector. When the line has been removed, check the fitting for oil leakage. Reinstall the exhaust collector drain line. If you note oil passage during the inspection, contact your solar field service representative or service manager.
Inspection of the bleed air valve is performed as a part of the intermediate maintenance inspection. Inspect the bleed air valve and its component for nicks, cracks, scoring, or damage. Check your operation and maintenance instructions for warnings and safety precautions prior to performing maintenance. Shut down the unit. Turn the master switch off. Be sure the post lube is complete prior to securing the fuel and service gas. Turn off the fuel and service gas and tag them. Turn off the circuit breakers and tag them. Remove the safety wire from the insulation blanket. Then move the blankets to gain access to the bleed valve mounting hardware. Begin by spraying the valve hold-down nuts with penetrating oil. This will aid in their removal. Warning: you may have to use rags if the engine is hot to protect your hands while removing the bleed valve and duct assembly. Next, loosen and remove the bleed valve duct. Break the cover bolts loose at this time in order to aid in their removal after the valve has been removed from the engine. Now loosen and remove nuts and washers at the bleed valve mounting flange. You will have to tip the valve to do this step because there is no clearance for removing the nuts and washers with the valve in place. Lift the valve clear of the engine. Be sure to cover the engine opening to prevent the entry of foreign objects. Warning: be careful while removing the cover in the next step. There is a spring inside that can possibly fly out and injure you. Remove 6 of the bleed valve cover bolts. Place one hand over the cover to overcome spring tension. Then remove the last 2 bolts. Remove the cover gasket and discard it. Next, remove the piston, spring seat, shims, and spring from the housing. We will now visually inspect the components for nicks, cracks, scoring, or damage. Check inside of the housing thoroughly for signs of damage. Next, inspect the spring. Check that the proper amount of shims are installed as specified in the operation and maintenance manual. These shims are used to compensate for altitude. Check for dings inside the spring seat hole. Check the adjusting screw and lock nut on the piston for tightness. Do not adjust this screw. It is a factory set. Check the end of the screw for wear. Next, clean the components with a lint-free cloth dampened in Stoddard solvent. If any parts are found to be defective, replace the valve. Now install the spring. Next, install the correct amount of shims. Then install the spring seat. Install the piston. Check the piston for freedom of movement by pushing the piston into the housing, then slowly releasing the tension. The piston should move freely. Install a new gasket. Install the cover and two mounting bolts. Press down on the cover and secure the two bolts to hold the cover. Put in the other 6 bolts